All right, let's jump right in. We hear all the time about how AI is going to revolutionize medicine in these shiny, state-of-the-art hospitals. But what if I told you its biggest impact, its true calling, might be somewhere else entirely? Today, we're going to look at how a totally new kind of AI could become a co-pilot for healthcare workers in some of the toughest, most challenging places on Earth.
First, I just want you to look at this number, 939,978. Just let that sink in for a second. What on earth could that possibly be?
Well, that is the number of accredited social health activists, or ASHs, in India just a few years back. They're part of this global force of community health workers, the real human frontline connecting remote communities to the healthcare system. For millions and millions of people, they are the only lifeline they have. So, to really get how AI can help, we've got to understand their world first. We'll start with the human frontline. Then we'll check out the promise of a digital co-pilot. We'll have to cover some critical issues like caution and bias before we introduce a really cool potential solution, a specialist in a pocket. And finally, we'll ask the big question, what does the future of care actually look like?
Okay, so let's start right there with the reality on the ground. What does it actually mean to be a community health worker, day in and day out?
Well, the challenges are just immense. Their connection to the bigger, formal health system is often hanging by a thread. Their training might be piecemeal, they're short on resources, and get this, many of them do this incredibly vital work for little or no pay at all. They're really driven by a deep commitment to their communities, but so often they're left to fend for themselves.
And the stakes? They are incredibly high. I mean, imagine you're hours from the nearest clinic, and you have to stop a life-threatening bleed. You've got to know to expose the wound, apply firm pressure, and if that doesn't work, you have to apply a tourniquet perfectly, not over a joint and just tight enough to save a life. These are literally life-or-death decisions being made with hardly any backup.
And this is where the whole idea of a digital co-pilot comes into the picture. Could artificial intelligence actually help bridge some of these massive gaps in resources, training, and support?
The potential is honestly, it's staggering. We've seen AI do incredible things, like diagnosing diseases with superhuman accuracy, reading complex CT scans and MRIs, and even predicting the best possible treatment for a specific patient. It can even screen for eye disease from a simple photo, literally preventing blindness. The promise is so clear. But, and this is a big but, the reality is a whole lot messy.
Right, because for all its power, AI is still an imperfect tool. And when you're talking about the front lines of care, that means we have to talk about the code, the caution you have to use, and its real-world performance.
Now, check this out. This is some fascinating data. When you test some of the world's most advanced AI models against established trauma guidelines, well, they're not perfect. ChatGPT-4o gets it right about 73% of the time, and Gemini Advanced is just under 70%. Now, that's really impressive for sure, but in a life-or-death situation, what about that other 30%? That's a huge margin for error.
And the researchers themselves, they basically said it all. Their conclusion was that despite how sophisticated these models are, they're just not yet clinically safe for frontline trauma care. They're a powerful asset, no doubt, but they are not a replacement for human expertise.
So why does this happen? Well, a huge part of the problem is bias. See, if the data used to train an AI doesn't reflect the real world with all its diversity, the AI just won't work for everyone. Vulnerable groups are often missing from these data sets, so an algorithm trained in one part of the world might completely fail for patients somewhere else. It can even end up copying our own human prejudices, baking historical inequalities right into the code.
So, the challenge is pretty clear. How do you actually use AI's power while protecting against its flaws? This brings us to a new kind of approach, an integrated solution designed to act like a specialist in a pocket. And one project exploring this is called Health Guardian.
The secret sauce here is something called neurosymbolic AI. Now, I know, it sounds super complicated, but think of it this way. It combines the amazing pattern-matching intuition of a neural network, like Google's Gemini, with the rock-solid, rigid logic of established medical rules, like protocols from the World Health Organization. And here's the key part. It shows you its thinking, so the user always knows if the AI is reasoning or just following a strict, safe checklist. And to pull all this off, a system like this uses a whole suite of different Gemini models, each one picked for a specific job. For example, it might use the deep reasoning of a model like Gemini 3 Pro for a really complex triage, but then use another model's vision skills to identify a snake from a quick photo.
It can even use live audio and video streaming to act as a real-time sonographer, guiding a health worker's hand. It's like a Swiss Army knife, but for frontline healthcare.
So that's the tech, which is incredible. But the real question, the one that truly matters, is this. How do we actually connect that raw human need we saw in the front lines with the real potential of this amazing technology?
Let's walk through a scenario. A patient is having a seizure. The health worker quickly puts in the symptoms. The system uses its deep reasoning to do a triage, and bam, it immediately flags a critical threat. Step 1 is just recognizing the danger, and fast.
Okay, but what's the cause? The health worker spots a snake nearby and snaps a picture with their phone. The app's vision model instantly analyzes it, identifies the species, and cross-references its database to confirm. This snake is venomous. The diagnosis is now specific and totally actionable.
And this is the game changer. The system doesn't just stop at diagnosis. It becomes an agent. It can kick off a simulation to dispatch a drone with emergency supplies and at the exact same time use its mapping tools to find the nearest clinic with the right antivenom in stock. It connects the diagnosis directly to the solution.
But what about when there's no internet? Which, let's be real, happens all the time in these areas. This is where the design gets really smart. When it's connected, the app uses the full power of the cloud AI. But the second it goes offline, it flips into edge mode, running on simple, reliable rules stored right there on the device. This makes sure the app is always a dependable tool, not a useless brick when you need it most.
All of this, it really points to a fascinating shift in how we think about this technology. It seems to be less about replacing what humans can do, and way more about enhancing it. It's a move away from just artificial intelligence and toward what you might call augmented humanity.
And this diagram here illustrates it perfectly. You see the health worker, the provider, right at the center. But their effectiveness depends on everything around them: the community's beliefs, the health system's resources, you name it. A tool like this isn't meant to replace any of that. No, it's designed to be a bridge, to make the connections between all three of those circles stronger.
So, we end up with this question. Maybe the goal isn't just to build smarter and smarter machines. Maybe the true revolution in healthcare will come from using those machines to empower the humans on the front lines, creating a future that's built not just on artificial intelligence, but on augmented humanity.